Welcome to the new Cyber Frontier, bringing you the latest news on the local Colorado economy and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host, Chris Gorog, brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. Chris is personable and opens up with our guests on issues we all would like to see addressed. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's new Cyber Frontier.
Welcome and thanks for joining today. Our guest, Roger Hill, is the CTO of Veracity Security Intelligence and the former Global Head of Technology Development at Siemens Corporation, one of the largest industrial controller corporations in the world, manufacturers in the world. We're going to join our conversation a little bit into it here because I wanted to catch the candid kind of conversation about some releases that they just had at Veracity. I hope you enjoy.
So we just, well, actually, since we met, we just secured our funding.
Awesome.
So, yeah, fantastic. So it's been a race onboarding our team.
Is this something we can get on the podcast?
Well, it's an early seed round, but hey, $1 million of funding, I'll take it, right?
But I mean, is this something we can announce on the podcast and we can talk about?
Sure. We've got a press release coming out with Microsemi. So, we're pretty excited about that. But now we're actually bringing on, I just hired 2 developers out of the NSA.
Okay.
So I was up here, they're going to be working home office. We're very, very distributed. Everyone's working geographically dispersed. So I'm trying to spend a lot of time face to face with everyone first. So right now I'm doing a lot of traveling, and I'm afraid it's going to even peak because I need to start getting in front of customers and doing validation calls.
All right. So was this an investor? Was it the company you had talked to me about?
Microsemi Corporation.
Corporation.
They were a very, very large chip silicon supplier.
Okay.
They do a lot in the federal space. So a lot with time-sensitive chips, FPGAs, that sort of thing. So specifically, what was attracted to us is they had acquired a company, Vitesse, and they were supplying the chip vendors of industrial switch vendors. So that was where we focused. But they're big. Microsemi's big.
We'll be right back with the rest of today's show right after these brief messages from our sponsors. Cyber Resilience Institute helps build strong cyber communities designed to prevent members from attack. Like building a neighborhood watch, it takes coordination and a sharing community to protect our identities and valuables in the virtual world. Typically, we hear that organizations know they need to do something to protect their cyber assets, but don't know where to begin. Let Cyber Resilience Institute help your community create an action plan. Cyber Resilience Institute will build your community or business marketplace so that it is designed to support a collective cyber defense. Contact them for more information at cyberresilienceinstitute.org. So
let's go back and let's say, tell us about Veracity. Tell us what you do. Give us your background. We kind of just released that you got your phase of funding here, first round, and moving forward. Tell us about the company, though.
Yeah, so Veracity Security Intelligence, I've been with them for about a year. We've been at it for about a year and a half. We are a cybersecurity solution for industrial networks. The short version is we're applying some SDN principles to addressing the visibility problem.
Define that.
Acronym hell.
Yeah.
Right, got to stay away from that. So we're applying software-defined networking principles.
Okay.
To some of the problems that we have within industrial networking, and industrial networking is what connects a lot of our critical infrastructure together.
Okay, give us a brief understanding of software-defined networking.
Right, so traditionally within an Ethernet switch, where you plug in all of your cables, there's multiple layers within that switch. There's what we call the data layer, or that's the actual physical interfaces that's forwarding the packets or the streams between one port to another port. So then you have a control plane above that, and that control plane is essentially telling that data plane how to forward those packets, right? And then you have some different applications on top of that. They're very closed systems, and each vendor has their own version of the software and of their switch. And everything has to interoperate together magically via all of the 5,400 RFCs that are out there to date with all these distributed protocols. I'm going to do this. Is that okay? No, I'm going to do this. No, should I do this now? Should I? I'm going to do this. Is that now? It's crazy. It's crazy. It's madness. So essentially, you have this environment where now academia is in there saying, okay, all of our grad students, we need to get out there and start doing some research on networking.
Mm-hmm.
How do we even start doing this research when it's closed systems?
Mm-hmm.
So
So
it's almost like a
proprietary,
meat
every company.
Absolutely. So it really came out of Berkeley and Stanford. They were looking at this and saying, well, wow, why can't we take that control plane? What if we were to separate that, and let's just throw that on a PC, and have that control plane communicate to many switches, or the data plane.
Mm-hmm.
So it's a centralized control plane. Well, then what we could do is we could further abstract. We're using some software development principles of layers of abstraction, if you will,
Mm-hmm.
and have a northbound API or application programming interface that would allow applications to run in that layer, in a business layer, logic layer.
Mm-hmm.
So then this would create an environment where they could do their research. Well, not long after this, it was all kind of academia. It was really interesting. There was a lot of buzz about possible potential with software-defined networking.
Mm-hmm.
And then all of a sudden, Google came out and said, yeah, we actually did it. We went out to an ODM, original device manufacturer in Taiwan, built our own switches, applied our controller. All of our data centers are software-defined networking.
Mm-hmm.
Now that just created, oh, wow, if Google did it, it's real. It's no longer theoretical. So then there was an explosion of different markets, if you will. So, for example, if you look at the carrier-grade networks, the AT&Ts and Verizons of the world, they had the situation where, quite frankly, these devices, right? An explosion of mobile devices.
He's holding a phone up there.
Yeah. So it created this environment where every 18 months they had to replace these switches they had. Now, these switches, they were 700 interfaces, 40 gigabit, tremendously expensive.
Mm-hmm.
Now, this is a fantastic situation for all of the switch vendors because
So
they're
what we're
selling
saying
boxes.
now is we've made specialized equipment not required. So these companies that were spending all kinds of money every time they upgraded from G4 to G5 phones had to totally replace their networks.
And people keep having kids, and those kids get phones, and it's exponential growth, right?
Uh-huh.
So it's been an explosion. So they've had this situation where literally these carrier-grade networks, they couldn't keep up. They needed a better solution. And then introduce the concept of a white box switch, where it becomes almost irrelevant. And then what you do is you drive that with a software-defined networking controller.
Mm-hmm.
And that was really one of the first real business cases that seemed to have some real traction. The other one is really within the data centers. Now you see software-defined networking for corporate WANs, SDN for Wi-Fi. There's been all of these different segments and industries looking at it, and it's all built around different use cases or drivers around network agility.
Mm-hmm.
Now, on the industrial side, where I'm at, so this is the networking within a shop floor that's assembling cars, that's making cars, or it's producing Coca-Cola, or energy, power substations, that sort of thing. Within these environments, it's a very different scenario. They have much different requirements than you see on the enterprise.
Mm-hmm.
And quite frankly, the communication profiles, these devices are there for 15 to 20 years. So the communication characteristics, they don't change.
Mm-hmm.
There is no business driver around network agility. I'm looking at this and thinking there is something around security agility. So it's very common to talk about defense in depth principles, or the security onion within the industrial control systems,
Mm-hmm.
where we're going to take a very layered approach, and there's no silver bullets, and we're going to design these these segmented layers. But if you think about it, it's almost like we're approaching the security problem from a waterfall development process that you see in software development.
Mm-hmm.
Let's plan for everything we can ever imagine, then develop it and see if somebody wants it, right?
Mm-hmm.
That's the problem with the waterfall
I
development
agree with that.
process.
I've seen that.
So if you think about it, the idea of building out your segmentation and whether you're doing security zones or security enclaves and how they communicate across each other, if you're trying to design this for every threat vector and actor, that's just not a reality.
Mm-hmm.
What we can look at now with what Veracity is building out is now what we can do is all of this traditional segmentation and segregation that you do between these devices. Now you can do this programmatically. So you can actually design, okay, we have this threat level. Let's call it DEFCON 1. This is everything's happy, everything's normal. Let's just make sure there's not something already malicious on our network. And let's define an acceptable use policy. Who should talk to who over what protocols? Or we like to simplify it to the point of think of things as just conversations,
Mm-hmm.
even for machine to machine. What are the conversations that these two machines have to have? So then we can actually lock down that profile, assign it to that threat state. And then we think about, okay, well, what's the next level or next threat level state? Well, that's where maybe we discover something malicious
Mm-hmm.
on an asset within our network. So what do we want to do in this case? What we're doing with this type of an approach is we're trying to think of what is the mission critical function of these machines, because there's been this explosion of, even with the smaller PLCs that control the actual process.
Programmable logic controller.
Logic controllers, right? So these, when you hear about the Internet of Things, these are the things that are controlling the things, right?
Mm-hmm.
In the industrial context. So even with the very smallest level of these things, every single vendor has an integrated web server, integrated FTP server. It's madness. And in many cases, they're enabled by default. So these are additional threat vectors. So what we have to do, we have to look at what's the mission critical function of this machine.
Mm-hmm.
Does it need to have web access? No. So we disable that. So we start to restrict the mission critical functionality with the rising threat level.
So you're doing this in the levels of your software-defined network, though, correct?
Absolutely. And so we can do this programmatically. So I'll give you another very specific use case.
Go ahead with your use case, and then I have a question on that. Go ahead.
Yeah. So, one interesting aspect, a lot of these systems are very, very complex. So the actual automation vendors many times will have a maintenance contract with that customer to actually manage and configure the motion control systems and for all the different axes and everything else. So then they have to have remote access into the facility. Mm-hmm. How do you do that securely?
So they have a backdoor and a password into every system just to go in and make a small change.
Plural, right?
Yeah, exactly.
So it creates a nightmare scenario. So then even when you look at some of these companies that are focusing on, managing this, and they'll have what they call like a jump server, where once I've authenticated a user, I'll bring them into this server that will then connect into the relevant systems, allowing that vendor to do the configuration.
Okay.
No matter how you try to secure that, you leave that threat vector there.
Mm-hmm.
So in this new world, you can actually design a cell of one asset, just that remote access server, so that virtually I am literally unplugging that network cable. It has no connectivity. Mm-hmm. If I have no connectivity, I've reduced that attack vector or the attack surface tremendously. Mm-hmm. Then when I have an authenticated user, once they're authenticated and authorized, I then plug in that virtual cable. They're allowed to do what they're predefined allowed to do in a certain area, while fully tracing everything that they do touch until they're done, and then the cable's disconnected again. So now, even if something did happen by that vendor, you have full traceability. Mm-hmm. So it can aid you in an incident response. So that's the new way of thinking about this connectivity. It's thinking really outside the box. It's looking at being able to route really programmatically based on demand. So some of the early resiliency tests that we've seen in the industrial sector, I think the fastest industrial high-speed redundancy protocols that exist today are somewhere in the neighborhood of about 90 milliseconds of recovery time when you have a link failure. Now we're looking at 100 microseconds. So take away just the security value proposition that becomes very viable with this type of a solution, just from a pure redundant and resiliency of the network for industrial systems.
So you're speeding up the ability to make very quick communications as well.
Absolutely.
Okay, so interesting. I mean, there's a lot we just absorbed here.
Fire hose.
I would have to say that, Roger, I talk to lots of people about cybersecurity, and everybody talks about what needs to happen, what somebody else needs to do, what the people need to fix. You're actually doing something. I'm like very impressed. I mean, compared to the hundreds other people you talk to in cybersecurity, you guys have a path, a product, something you're putting together. You know, it sounds like it's a piece. It's a good step in an industry that really doesn't have much, but it's hard to find a solution that looks at solving a problem in the industry, and I applaud you for that.
We'll be right back with the rest of today's show right after these brief messages from our sponsors. Cyber Resilience Institute helps build strong cyber communities designed to prevent members from attack. Like building a neighborhood watch, it takes coordination and a sharing community to protect our identities and valuables in the virtual world. Typically, we hear that organizations know they need to do something to protect their cyber assets, but don't know where to begin. Let Cyber Resilience Institute help your community create an action plan. Cyber Resilience Institute will build your community or business marketplace so that it is designed to support a collective cyber defense. Contact them for more information at cyberresilienceinstitute.org.
I would have to say that, Roger, I talk to lots of people about cybersecurity, and everybody talks about what needs to happen, what somebody else needs to do, what the people need to fix. You're actually doing something. I'm like very impressed. I mean, compared to the hundreds other people you talk to in cybersecurity, you guys have a path, a product, something you're putting together. You know, it sounds like it's a piece. It's a good step in an industry that really doesn't have much, but it's hard to find a solution that looks at solving a problem in the industry, and I applaud you for that.
Well, it's really interesting, Chris, when you look at it, and what really drove me is to get away from that iterative innovation cycle. We keep applying all of these different Band-Aids, and there's a lot of startups out there right now that are focusing on new Band-Aids. They stick better.
I understand that. I hear them all the time.
Band-Aids, right? So rather than looking at this, why are we doing things the way that we're doing things? What are those constraints? What would it take to remove those? And that's really what led to this idea. One of the inspirations for myself was in the early days, looking at VMware. And I was so fascinated with VMware and what they were doing by virtualizing the IT space. In my opinion, they really revolutionized and brought some real disruptive technology because they drove this evolution within IT that created IT services, where IT could provide different services to different businesses and charge by use, by creating these breadcrumb trails of your business is utilizing so much CPU utilization, so much memory, and I'm going to charge you accordingly. The way they could do that was by virtualization. What made VMware so successful, though, is yes, they had the initial technology, but what they really did is they brought together an entire ecosystem of solution partners, and they said, come compete against us in developing applications in this space.
Yeah.
That's what drove the disruption. And that's exactly what I would like to do. There's a lot of great people within the industrial control system cybersecurity community as a whole. And a lot of these people, though, are working on the same problem definition, the same problem set. And
so what is the most common problem set? I have some ideas, but I'm curious.
Yeah.
What would you say it is that everybody's trying to solve and combating each other? And is it even the right direction?
It's very basic, actually, in my opinion. Um, the number one problem from a networking perspective is pure visibility.
Mm-hmm.
So, if you talk to a CISO that was just informed that he now has ownership of this OT or operations technology, their manufacturing plants, right? Well, okay, what's the first question if I inherit something? Well, what did I just inherit?
Mm-hmm.
What's on that network? What do you mean you can't tell me what's on that network? I have to know what I have before I can formulate a plan of
Mm-hmm.
how to protect it and take a risk-based approach. So the number one problem is visibility, and that's due to several different factors. The industrial networking, the IT space that's trying to approach the problem, they're approaching it as if that infrastructure is the same infrastructure they're used to within the enterprise.
Mm-hmm.
They're used to everything having a span port. What a span port does is all of the different ports on the Ethernet switch, it copies all of that data out to one port so I can literally look at everything. Well, in the industrial sector, the further you get closer to the actual control layer or the PLCs, there are no span ports,
Mm-hmm.
right? So now you have a choice. How do I see that data? I install a bunch of taps, which can basically take a copy of that data, or how do I achieve that visibility? Uh, so it's a nightmare. That's the iterative innovation that we need to disrupt.
Mm-hmm.
All of the industrial switch vendors that are developing competing redundancy protocols in the future with that centralized software-defined networking concept, you can run network analytics where you can on the fly provide orchestration and rules that you're pushing, which is creating matches on that switch and associated actions like I'm going to move this out to port 5, port 6. You're doing this in a centralized, orchestrated way, but with distributed execution. That's the elegance of it.
Mm-hmm. So whenever you were talking earlier, you said virtualization, software-defined networking. You're separating your hardware with a couple layers so that there's a stack that you understand everybody interfaces at the top the same and every hardware interfaces at the bottom uniquely. So I get that. One thing that when you brought up virtualization and the power there, virtualization also causes a lot of issues where, I mean, for instance, a virtual machine and a physical machine, the definition of virtuality is there's no way to tell the difference. So now you have the ability to recreate mirror images of machines out there. And just want to curious what you think about this, because in the industrial control space, trust of that command, because there's electromechanical operations happening over these networks, is very important. So you add the virtuality in there, you kind of add another unknown perspective of, am I talking to a real machine or a virtual machine? So kind of connecting that physical and
Right.
software, separation, the software-defined networking. What's your thoughts there? I mean, it seems like there's an important piece here that we might even actually need to address later.
Yeah. So, yeah, very interesting. So one of the very first things that I'm going to have to address, and which is very interesting because for the industry as a whole, has been on an awareness campaign for about 7 years or so to raise awareness for ICS security, right?
Mm-hmm.
And we've really progressed within that. Now I'm providing ICS security, but I'm utilizing software-defined networking. I find myself in that unique position of now having to raise awareness of what software-defined networking is. There are many, many misconceptions. For example, equating this to virtualization, I think what you might be thinking about is really NFV, or network function virtualization. Network function virtualization looks at what we call middle boxes. A middle box is anything responsible for the forwarding of a packet: a firewall, an intrusion detection system, an intrusion protection system, a router, right? Network function virtualization looks at virtualizing these appliances. Software-defined networking is complementary to NFV, but completely different. Software-defined networking is not virtualization. Software-defined networking is literally that centralized orchestration of the pushing down the match fields and the associated actions to each of the switches and getting those counters and responses back to have that centralized view and running those analytics. So they're really quite different. Now, to answer your question, though, about virtualization, it's already here within the factories. I would say in many aspects, about 10% of the customer base, they're already running some form of virtualization. Specifically, the Microsoft-based PCs that are running some of your runtime operations, such as SCADA servers, SCADA clients, batch servers, engineering workstations, are already virtualized to a certain extent and running on ESX or VMware platforms within the plant floor. So it's already there. What you have to think about in terms of risk between that physical layer and the virtual layer, though, is that interconnectivity. And that's where we've seen some of the problems. Today, that's built upon something what we call OVS or a vSwitch. So the first thing we developed was our industrial virtual switch. So that industrial virtual switch runs on that hypervisor and provides that virtual connectivity or that virtual connection between those virtual machines and the physical interface of the physical box, and ties it into our controller so that we can define our white flow directives or security policy to those virtual devices, as well as the different switch vendors that we're working with to control and provide security orchestration.
Okay, so the layers of the software-defined networking are not independently updatable by the vendors. Can patches be run on them?
Yeah, so we have to think about what are we defining as patches, right? So let's just step back in time for just a moment and look at the traditional Ethernet switch. And remember, there's the physical layer or the data layer, right? The control layer and the applications. Yet when there's an update, like a firmware update, it's addressing all three layers simultaneously. In this new world, it's slightly different, right? Because now when you have that centralized orchestration, the applications are an abstracted layer, so you can update your applications all day long and never have to think about what's happening with your underlying infrastructure. All right, so that's point number one. Now your centralized controller, you can also provide updates there because that controller is not continuously communicating to the switches, especially in the industrial networking. Once I push down that configuration, and remember, it's the same devices communicating over 10 years, unless something happens where I need to give it an update, it might not, other than a life beat and get some counter statistics back, I don't need it plugged in. So I can update that controller. And we're designing HA into it as well. Now, brings us down to the last layer, the physical layer or the data layer, right? Now, these industrial Ethernet switches we're working with, even though they have the same three layers still built in, what we're literally doing is pushing down the configuration through our framework. So if that switch vendor has an update, the same rules that they've always had for their firmware would still apply in that sense. But now what we can say is the other applications and controller won't have as frequent cycles and it won't have as much impact. So it will definitely be an improvement. Now we still have to work on in the future, and this is a bigger problem to solve. This applies to all devices. How do you provide updates in a way that would not disrupt its mission critical functions?
Yeah. So you mean that in the time it takes to update it, maintain usability type of thing?
Yeah,
So.
Absolutely. Because if there's a big school of thought out there, if it's not broke, you don't fix it. And in fact, there's a lot of industry sectors where you cannot touch that configuration. You can't apply that, or you will have to revalidate it.
Yeah. Have you thought to maybe this is just something I know we've done in a couple other industries, a ping pong approach. So having two separate, at each layer, two separate usable pieces that you can load and update in one and then migrate over.
Yeah. So for high availability systems, where we're running redundant PLCs, we're running like a parallel redundancy networks, where we have an A network and a B network, and then we're running redundant SCADA servers. Yeah, there's currently, you can use the same good best practices for patch updates, where if A is the master, well, you update B.
Yeah, or even the same, at that layer, you have a a supersession. So you load two side-by-side, basically software pieces, make sure the second one's working, and then migrate over.
Yeah, yeah. There's a lot of different approaches right now, but what we're driving in trying to apply a lot of the good software development architectures of abstraction layers. That's what software-defined networking brings. So that's our focus area right now, because what we're targeting are not this next generation of industrial control systems. What we're targeting are what we call the brownfields, meaning the factories that have 15-year-old pieces of equipment.
Okay.
That they're running NT4 Service Pack 6A. Mm-hmm. I know a lot of the kids that might be listening to this might be saying, well, what is that? But,
so you're looking at putting you're going to push this into legacy equipment. Absolutely. As well as next generation
because
equipment.
If you think about that, I have that PC, and it's running a legacy operating system. How it's connected to the network, whether it's traditional or software-defined networking, that operating system and the underlying applications have no knowledge of the network. Mm-hmm. They're just saying, send this packet out to my distributed partner, and I'm expecting this response back. That's it. So it's completely transparent to the actual assets or the devices.
Mm-hmm. Well, definitely, we've got really technical in this talk. I know that a lot of people aren't going to follow, but rewind it, listen again. But thanks for being on, Roger. A little bit. We didn't talk about your background too much. Obviously, you've worked somewhere to get to this wealth of knowledge. What is your background in the cyber arena?
Right. So before joining Veracity about a year ago, I spent just about 16 years with Siemens. The last 3 years there, I was standing up the security business for managed security service business for the Siemens industrial customers. So I was running the Global Technology Management Group, where we would evaluate different security technologies that we would identify that our customers needed today mm-hmm. and in the future. And also we evaluated a lot of startups and emerging technologies. Before that, I'd always been involved with industrial control systems, whether it's with SCADA systems or manufacturing execution systems, or even, the lower level systems in that entire 16 years.
Yeah.
Just about 25 years. I think how I got started, Chris, was really curiosity, how things work, right? And that's really what drove me. And it was really just a progression.
Yeah.
And all of those different experiences, I think, feed that ability to be able to see things with a very clear vision. And perhaps one thing that's always been unique is the way I approach a problem. And it's identifying a current problem. That's almost a gift to some people, because you have to identify a problem before you can identify a solution, right? And in that process of identifying the problem, not constraining yourself to work within the constraints of that problem or the system, but actually trying to step away
of it. Yeah.
That's right. Step outside that box. And what if those constraints weren't there? Let's define the ultimate solution. Then let's work backwards. Why are those constraints there? Is it just because there's been a very iterative-based innovation approach, where this is my device, my next feature will have feature X, Y, Z, so I'll build that one. Next version will have this. Mm-hmm. Instead of asking ourselves at some point, is this madness continuing like this? Is there a better way to do this?
Yeah.
When we think about these converging events with the whole IoT, the Internet of Things, not to mention, how many times are we hearing about a new cyber attack, whether it's a real cyber attack or not? So we have this convergence of events that's driving this. We have to stop the madness. It's not a time for Band-Aids any longer. It's time for real solutions.
I agree. And wow, once again, thanks for coming on today, Roger.
Thanks, Chris.
Great insight, and we look forward to watching Veracity and see where your solution goes and your company in general.
Hey, appreciate the time. It's been fun.
Yeah, definitely.
Thanks, Chris.
We hope you have enjoyed this episode of New Cyber Frontier. Remember to get involved. Often we think that someone else will handle privacy and security in the virtual world, but you are the only one truly in command of your virtual fate. Join our mailing list so we can keep you informed of breaking news and new releases. If you have an idea, if you have a question that you would like to hear answered, or if you want to get involved with our efforts, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors' links, as they are the ones that really make this show possible. I want to thank each of you for supporting the show, and we look forward to seeing you back for the next episode of New Cyber Frontier.